Good morning. I'm Bonnie Gardner. I'm co-chair of the Public Affairs Forum of the First Unitarian Universalist Church of Austin. We're located at 4700 Grover Avenue. Our forums occur most Sundays at noon, and they're free and open to the public, and we encourage you to attend. Today, Dale Beulah, a member of our forum committee, will introduce our speaker, Jim Spenser. Thank you, Dale.
Thank you, Bonnie. Good morning, everyone. I'm also a member of our Green Sanctuary Committee who is co-hosting this event today. It's my pleasure to introduce the Chief Weathercaster for KXAN, Jim Spenser. He joined KXAN in 1990 and in 93 became the Chief Weathercaster. He's now in his 25th year. He grew up in Lindsay, Oklahoma, in the heart of Tornado Alley, and he credits his lifelong fascination with weather with his childhood and growing up. He has been the past recipient of the National Weather Association's Weathercaster of the Year Award, five-time winner of the Texas Associated Press Best Weathercast Award, voted Austin's best weathercaster by the readers of the Chronicle for 16 years. He has a long history of involvement in community and charitable organizations as well, on the board of the Directors of Service Dogs, co-hosting the Jerry Lewis Telethon, community advisory for the Helping Hands for Children, also served as a court-appointed special advocate for abused and neglected children here in Travis County. Partnership is well known with the Family Elder Care Summer Fan Drive. He's also a member of the Advisory Council for Travis County Coming of Age program. And each year, of course, he teaches thousands, probably more than that, of area school children about severe weather and how to prepare for it and how to be safe in this area. Other than weather, he's also crazy about his nieces and nephews, and he loves football officiating. I bet you didn't know that. That's one of his passions, actually. He's officiated high school football for 31 years. He is also a member of the chain crew for the Big 12 conference officials during UT games, and has officiated scrimmages with the University of Texas and the Dallas Cowboys. So it gives me great pleasure to present William Spenser. Come and tell us what's the forecast.
Thank you. Speaking of the Dallas Cowboys, had I known 6 months ago when they invited me here this morning that they would be in round 2 of the playoffs, kicking off at this very moment, I might have recommended that they postpone this so that you Cowboy fans could be home enjoying. But the fact that you're here says a lot, and I really appreciate that. And thank you for inviting me here today. I'm just glad to see you all weathered the terrible ice storm that we had in the city yesterday. Obviously, it turned out to be kind of a non-event here around the Austin area, but it was one of those situations in which the temperature was very, very critical. Had it been 2 degrees colder, the flyover that we saw ice over up at 183 and 620 would have been one of many flyovers that would have iced over here in the city yesterday morning, and especially out in the hill country. So it turned out we only had a few, but the folks that were in traffic accidents yesterday morning because of those icy flyovers aren't very happy about it. But those situations in which it's marginal like that, and the computer models are telling us we're going to see ice, the National Weather Service really has no choice but to err on the side of caution and issue those winter weather advisories and winter storm warnings, and we're obligated, obviously, to pass those on to the community. I try to couch my language to maybe give you a little hint when I say I'm really not certain that we're going to get down to that threshold. When I say that, I probably really don't think it's going to happen. So keep that in mind. But we can't really come out and say, we don't think this is going to happen, because if I'm wrong and the temperature drops 3 degrees lower than I thought that it was and the city ice is over, then I'm in big, big trouble. So sometimes we just flat out miss it. Sometimes we think that something else is going to happen, but we have to provide the public with the information that the National Weather Service is providing to be on the safe side. And I did think we'd see a little more ice than we did, but we certainly didn't see very much around here. Well, today our topic is, and I've been invited to speak to you about the forecast. I think they were talking about long-term, but since I have you all here, a captive audience, I'll give you the short-term forecast. It's going to be warmer tomorrow, back up into the 50s, no more threat of ice anytime soon. We do have another cold front coming, though, on Tuesday and Wednesday. We're going to be back down into the 40s and probably not even any warmer than that. Maybe a slight threat of a little ice in the hill country Tuesday night. But other than that, I don't see any more significant ice or real cold weather coming for at least the next 10 days. Beyond 10 days, it's really kind of hard to say. But we'll talk more about the winter in the longer term in just a moment. So that's kind of what we're expecting for the next several days. Let's talk, first of all, because they wanted me to talk a little bit about our current status in terms of the climate, and then looking forward to what we're hoping will happen in the year ahead and beyond. The current status of the climate is that we're still in drought. Now, you may wonder, how is that possible? We had a normal rainfall year this past year in 2014, and in 2013 and 2012. Those weren't bad rainfall years either. We'll talk more about why that is in just a minute. But we've been in a fairly persistent state of drought since 2010. And as a result of the drought, or really the cause of the drought back in 2010, was the La Niña pattern. We talk a lot about La Niña and El Niño, and we'll talk some about El Niño today. But the La Niña pattern is essentially the opposite of El Niño. It's when that blue area there that you see in the Pacific Ocean, which represents colder than normal conditions, when that area develops, we tend to see less rainfall across the southern United States. And we had that form in 2010. And as a result, we saw something we had never seen before. In that one-year period from 2010 to September 2011, we only had 7.77 inches of rainfall in Austin, 25 inches below normal. That was the driest 12-month period on record, and our records go back to the 1800s here in Austin. In addition, we believe it is the most intense drought on record and most intense summer drought, that summer of 2011, that we've ever seen, well, since 1789, some researchers say, looking at tree rings that date back to 1550. So if you were around here, most of you were around here in 2011, I know you remember that incredible dry year and the incredible heat wave. As a result of that extremely dry period, Lake Travis dropped to its lowest level since 1964. We're not that far above that now. It was just 12 feet above its all-time low. Lake Buchanan dropped down to 5 feet above its all-time low, its lowest level since 1984. And, again, we're not a lot above that right now. We're still in trouble when it comes to our highland lakes. And as a result of that very dry period, what we call the Bermuda High, which sets up over us every summer and makes us have typically hot summers, well, it's set up over us, and because of the very dry conditions, it's kind of a feedback loop. It made it drier and hotter and drier and hotter, and it didn't move for the entire summer. And as a result, who all was here in the summer of 2011? Most of you, I'm sure, yeah. So I'm going to run through these really quickly, but these are just so fascinating because they were so significant in our weather history. Every major heat record that Austin, Texas held fell in that summer of 2011, including these. It was the hottest summer on record. We saw the hottest July, the hottest August, the hottest September on record. We had the hottest August temperature ever at 112 degrees. We had 90 100-degree days. The previous record was 69. I mean, to break a record that significantly is almost unheard of. In fact, I remember back in the 1990s when I started working here, we'd talk about the number of 100-degree days because our average is 12, okay? And we talked about the record being 69, and it was back in 1925, and some suggested that could that really happen? Because we'd only seen 30, 35, 40, occasionally 50 100-degree days on the outside. How could that possibly have happened? We wondered if the records maybe were skewed back then somehow. But we learned that obviously it can happen, and it did. We had 27 100-degree days in a row. That broke a record. We had the most 100-degree days ever in August and September. We had the most 90-degree days on record, 163 of them. We had 132 days in a row that we were 90 degrees or hotter. That broke a record. The hottest average high temperature in August, okay, this is a whole month now. The average high in that month was 105 degrees. Just something unbelievable. The average low barely got below 78 degrees or 79 degrees at night. And finally, it ended up being the hottest year on record in Austin, Texas, in terms of the average temperature. So then we had the summer of 2012, and everybody remembered that as being, hey, this isn't that bad of a summer. Well, we still had 35 100-degree days when triple the average, essentially. And then the summer of 2013, we thought, well, this isn't so bad, but we had 42 100-degree days, and it actually ended up being the fourth warmest on record. And you notice where I'm going here. Every year continues to be hotter than normal. Now, this past summer, I think we'll all agree, it wasn't so bad. We had 21 100-degree days, and the average there is about 12. in terms of those 100-degree days. So many people are asking, is this just a new normal? Are we just going to have these brutal summers every single year? It's a good question, because when you just look back over the last 7 summers, 6 of them rank in the top 7 hottest since 1885. Okay, you take the top 7 hottest summers we've ever recorded since we started using thermometers back in Austin in 1885, and 6 of them have all happened in the last 7 summers. It's just remarkable, really. So we got through that summer, thank goodness, but then we got a forecast in September 2011 that the La Niña was forming again. Usually this is a one-year cycle. Occasionally they will go back-to-back, and that is indeed what has happened. So we thought, oh, this is horrible. This is the worst-case scenario. We've just had the all-time worst drought and the all-time worst summer. How much worse could this possibly get? And when the La Niña returns, of course, the forecast is that we're going to see a drier and warmer winter and spring. Well, fortunately, we were wrong. We actually had above-normal rainfall beginning almost immediately when we made that forecast. So we don't like that, but that's what happens. That orange area you see up there right in the middle of Travis County, for those that know the shape of Travis County, sorry I forgot my pointer, that little orange area there represents 35 to 40 inches of rainfall. Now notice the yellows and the greens back out to the west toward the hill country area there. That was 15 to 20 inches of rainfall in some areas. They're still well below normal there. And over the last 3 years, our rainfall has actually not been that bad. 2012, we had just an inch below average. 2013, we were ahead, actually, almost 7 inches. And this past year just ended, 2014, we ended up almost exactly normal at Camp Mabry anyway, with 35.5 inches of rain, an inch above normal. Now, the airport was below normal by about 7 inches, and the hill country significantly below. But here in Austin, we've done better. Your gardens, I'm sure you've noticed, have your lawns have stayed greener. So why haven't we seen improvement, and why do we still keep saying we're still in a drought? The very interesting thing about how this rainfall has fallen over the last couple of years, and it's been remarkably consistently this way, is that the distribution of the rain by month has been uncannily wet, then dry. This is 2012 right here as an example. March, wet. April, almost nothing. May, wet. June, practically nothing. July, wet. August, practically nothing. Just up and down, up and down. So what happens is, when the soil is extremely dry, it will take that moisture in, but then it all evaporates again during that dry month. It'll take it back in. We lose it again in that dry month. We never had any consistency to get the soil consistently wet so that it would hold that moisture for a longer period of time. And as a result, we've literally at times only gone a week or 2 or 3 weeks where we were considered drought-free in the Austin metro area over the last 5-year period. Literally just a couple of weeks at a time, including this past November and December. And this has happened. We've had these, I won't call them rain bombs, but I will call them significant flood events that have been very localized. For example, our Halloween flood in 2013. The heaviest rain there all fell down in the Onion Creek watershed. That white area there in Wimberley represents a foot of rain or more. And in northeast Hays County, that rain all went into Onion Creek, and we all know what happened at Onion Creek. People lost their homes. We lost lives in that flood on Halloween of 2013. Of course, we had a similar flood this past September. It wasn't as widespread, the flood that took the deputy's life out near Lake Travis in that flash flood, but that was a more concentrated flood event. Now, we have improved. There's no doubt about it. Back during that historic, intense drought in 2011, 88% of the state was considered to be in the worst possible drought status. That's the exceptional drought, we call it. That's that dark red, almost all of Texas. Today, only 2% of the state is considered to be in exceptional drought. But if you look real closely at our counties there in the central part of the state, portions of our, what we call our viewing area, out into the hill country, which is very important for us living here in Austin because the water that falls there is what comes into Lake Travis, which is our water supply. So it's very, very important. Big portions of the hill country there in Gillespie County, up in Llano County, are still considered to be right now, today, in severe to extreme drought. And in the Austin metro area, we are in the second drought stage called abnormally dry. First drought category, abnormally dry. And in parts of the metro area in the moderate drought category. So where have we gone today? So Lake Travis has gone up really nicely since we had all that rain the last couple of years, right? Nope, hasn't hardly changed at all. It's gone up. Occasionally we'll get a rain event out there and it'll go up 5 feet, 2, 3 feet, 3 feet. But today, it's 44 feet below average. Lake Buchanan is 24 feet below average. The inflows continue to be near record low. In fact, 6 of the 7 lowest inflows into the Highland Lakes, which fill the lake, we need good inflow to fill the lakes up. 6 of the 7 lowest on record since those lakes were dammed up and became our water supply back in the early 1940s have all happened in the last 7 years. So it's incredible what is going on out on the Highland Lakes right now. Okay, that's what got us to where we are at this point. Let's talk about the future now. These are what we call ocean heat anomalies, and essentially what you need to know if you look west of the United States and down southwest there into the Pacific Ocean, all the way over to Indonesia and Australia there, that area all being yellow and some orange is a good thing for us because that is warmer than normal ocean water temperature. And when it reaches a certain threshold, when it gets warm enough, we call it an El Niño pattern. And we have been forecasting since last spring that an El Niño is coming, an El Niño is coming. We were also forecasting back in the summer of 2012, an El Niño is coming, an El Niño is coming. And that was a false alarm. It did not fully develop. Every month since July, we've been just right on the cusp of what we could call an official El Niño pattern out there because of where the water is warm, called the El Niño region, and also the extent of a temperature above normal in that area. But it hasn't quite got there yet. What we're not seeing is the relationship between what's going on in the ocean and what's going on in the atmosphere. There has to be a coupling of that relationship before we can declare the El Niño has officially formed. And why is that important, an El Niño? What does it really mean? By the way, before I get to that, we've been forecasting this El Niño is about to develop, it's about to develop, it's about to develop since last spring. Our latest outlook was issued this past Thursday from the Climate Prediction Center, and they have dropped the percentage now of it developing at all. And back in, I remember back in the fall and the summer, we were telling you our climate models are saying we may have a strong El Niño. We had a strong El Niño. The last really strong one was back in 1997, and we had terrific rain. With wonderful rain. El Niño years will sometimes give us the type of rain that will fill the lakes, thinking back to the floods of 1991-92 on Lake Travis. They've dropped the likelihood of it developing at all to 50 to 60%. It has about a 2-month window now. If it doesn't develop next month or March, we can forget about it. And even if it does develop, it's likely to be weak. But when we can get a good El Niño out there and it starts to energize the jet stream, which is how it works, the warm ocean water, the evaporation off the ocean water, the energy coming off that heat energizes the jet stream. Storm systems form on that jet stream, that extended red area there, that river of air, and they typically move across the southern United States. And through the winter, fall, into the winter, into the spring even, we'll have storm system after storm system that'll bring us rain. Now, sometimes in the winter, they'll also bring us tornadoes. They'll also bring us ice and snow, so it's not all good. But I think any moisture around here we can all appreciate now. Unfortunately, during weak El Niños, what you're looking at right there is a map that shows departure from normal rainfall when we only have a weak El Niño. And we've actually found that they don't do us much good at all. In fact, we have winters that are just slightly below normal. That's statistically really kind of close to average there in our part of the state, but they don't do us much good. So if this El Niño does develop, we're not real optimistic that it's going to help very much. If we had a moderate El Niño, we have significant improvement in our amount of rainfall, at least a plus 2.35 inch increase from average rainfall. And if we have a strong El Niño, we see significant improvement, above average rainfall in much of Texas. But we're not expecting that anytime soon. But we're now we're 5 years now without an El Niño, with what apparently is going to be 2 false alarms. So it is coming back. It is cyclical, but it is time. We are overdue for an El Niño pattern. So what is going to happen, since we apparently are not going to get the El Niño, or not a significant one? This is the Climate Prediction Center forecast for January, the month. We're now almost halfway in. This was issued on the last day of December. It said we would be colder than normal, which so far that's been accurate, and wetter than normal. The top left panel, the top right panel. A means above normal, wetter than normal. So it looks like that is going to prove to be accurate if we can continue to get rain through the last half of January, although I'm not sure it's going to be that cold after the first couple days of next week for 10 days or so. Now let's go beyond January. January, February, March into spring. Notice still forecasting colder than normal, the blue, the B area, And green, it appears that the green doesn't go all the way to central Texas, but it actually does. We're just not seeing a real good quality here on this slide. Wetter than normal weather is forecast into March as well. But January, February, March aren't typically very wet months for us anyway, so that's not necessarily going to do us a lot of good. And then this is a panel that shows us rainfall beyond for the rest of the year, basically, all the way to 2016. And essentially, after the rainfall that we see in the top left panel there into February, March, and April, where we're above normal, you don't see any color on Texas the rest of the year, all the way down to 2016. It's called EC, or equal chances. In other words, the climate signals aren't leading us one way or the other. Essentially, it's a coin flip. We might be wetter than normal. We might be drier than normal. Our forecast essentially is average. So if we at least have average rainfall, that would be nice. We're always accused of just flipping the coin to make the weather forecast anyway, so 50-50. 50-50 chance that we'll have a wetter or drier than normal 2015. What about temperatures? Well, now, this is the first bit of good news I've had to report in 6 years. Colder than normal weather into the spring. The B, the blue B, top left panel, top middle panel, blue, and the top right panel, April, May, June, below average temperatures. So we might have a nice cool spring and into early summer. Around here, summer can start in early spring, or certainly by mid-spring. So that could be good news for us. That would be nice. But then beyond that, the good news is May, June, July, August. They do this in 3-month forecasts. July, August, September. Notice all EC, no color there, no orange, no blue. At least we have a 50-50 chance of having a normal summer. That's the first time I've seen that in 7 years from the Climate Prediction Center models. Every year they've been, you're going to be hotter than normal. And that's one forecast that they've been right about most years, is that we've been hotter than normal. So we're optimistic that this may be the year that we get a normal summer. Wouldn't it be nice to have a summer where we only had a dozen 100-degree days? That's supposedly the normal. The new normals are assigned every decade. When this next decade normals come out, our number of 100-degree day averages is going to be shooting way, way up. So, because of the rain that we've seen recently, we've seen drought improvement. Is the drought ending? A lot of people would say we're not really in drought right now. We're borderline drought in the metro area, and that's just in terms of our soil moisture content. We're looking pretty good right now where we live. Out in the Highland Lakes, we're still in a terrible drought situation. Is the drought ending out there? Not anytime soon, but it can end overnight. We had a 10-year drought. Our worst drought of record, by the way, is the 1940s and 1950s drought. In 1952, we had 25 inches of rain that fell out over Gillespie, Llano, into Blanco County, which is the perfect location for it to all flow into Lake Travis, and it did. And that 25 inches of rain sent Lake Travis up 56 feet in 18 hours. But the lake was down so low that filled the lake. Didn't flood the lake, it filled it. It was perfect. Now, if we had today a 56-foot rise in 18 hours in Lake Travis, can you imagine that? You could stand out on the bank and watch the lake rise. You could literally watch it rise. And that lake is long. That's 65-mile long shoreline. That is a lot of water. And you could literally watch it increase. If we had that happen today in 18 hours, it would be incredible damage out there because of the development that's taken place. People's docks, people's boats, marinas, they wouldn't be able to get them, taken care of and protected fast enough. There would be a lot of damage. We don't want that kind of increase in the lake level, but we certainly would take another kind. So we're seeing a little temporary break potentially in the drought here locally, except out in the Highland Lakes. But could our Highland Lakes drought last until 2030? Our state climatologist recently did an analysis where he says we may be in a multi-decadal drought right here. He says we know from the drought of 50s and looking at tree ring data that our area does experience droughts that last a decade or 2 decades, dating back years and hundreds and even thousands of years. Certainly looking at tree ring data dating back hundreds, we can see that this has happened before. He says, and unfortunately, if you go back to our drought of record in the 1950s, he sees a lot of similarities to what's happening right now. That's the only time in the past 100 years when the ocean conditions had a similar configuration to what they are today. He's talking about this multi-decadal pattern that we see set up in the Pacific Ocean and in the Atlantic Ocean. And when they are opposite, like they were in the 1950s, we can have a drought that goes a decade or longer. And he believes that we may be in that period right now. So this drought could be mainly drought to 2030. Now, again, it can end overnight. With this whole drought could end with one tropical storm, in August, or this spring with a certain storm system setting up in just the right way. But in that drought of the 50s, when we had that record increase on Lake Travis overnight, and the drought ended overnight, we immediately went back into a drought that continued to 1957. So it may end, but it may also be a very brief end. So is this drought and what we've been experiencing lately, this incredible heat, because of climate change? Well, there is no doubt that the climate is changing. 2014, we have just concluded, according to the Japanese Meteorological Agency, who's done the first analysis. More analyses will be coming out, at least a half dozen of them, including from our National Centers for Environmental Prediction and a National Climatic Data Center. You'll see a lot of these coming up here pretty soon. But the first one that's come out has identified 2014 now as the hottest year on record globally. And what's very interesting is that this isn't just, an unusually hot year this year, last year. 18 years in a row have been hotter than average. And in terms of the Earth, look at that, 38 years in a row, the Earth's average global temperature has been hotter than the normal. Who can look at that and say, oh, well, there's no global warming? I mean, if you don't believe that the planet is warming, you don't believe in thermometers. And this is really fascinating. 10 of the warmest years on record globally, looking back since we have good, thermometer readings back to 1880, top 10, 1 through 10, the top 10 warmest years on the planet have all happened since 1998. And now it's going to be 11. Let's add in 2014. The top 11 warmest years on the planet have all happened since 1998. So not only is it warming, not only are we warming, we're warming rapidly. Climate change is real. Temperatures are up 1.4 degrees in the past century. Projections from climate scientists and climate models are that we'll climb another 2 degrees during this century. At worst case scenario, 11.5 degrees. If that happens, we're in a lot of trouble, if we're at the worst end of that scale. We're already seeing the changes in sea level, more frequent droughts and floods, glacier ice melt. And let's just not mince any words. Humans are largely responsible. Burning fossil fuels releases incredible amounts of CO2 into the atmosphere, these greenhouse gases. You all know how that works. You've had a lot of environment talks in here, I understand, which I think is wonderful. You know how that works. They blanket the Earth. They trap the sun's heat and warmth without allowing it to radiate back into space. And this just isn't me, Jim Spenser, telling you that climate change is real and humans are largely responsible. I'm not a climate scientist. If I'm having a heart palpitation, I'm going to go see the heart doctor. Okay? When I'm worried about the climate, I defer to my peers, my colleagues that are climate scientists, that do this for a living, that know a whole lot more about this than I do. And 97% of my cardiologists tell me I have a heart problem. No, I really don't. 97% of the climate scientists say we are responsible for what is going on right now with the warming. Now, are we responsible for all of the warming that's taking place? Could there be some cyclical variation that just so happens to coincide with the beginning of the Industrial Revolution that's causing us to warm? That could be playing a part. Can't argue that. But we are primarily the cause. 97%. And that's not even as high a percentage as some studies indicate. Jim Powell, who is past president of the National Science Board, did a study through 2012 where he looked through almost 14,000 peer-reviewed climate articles. Now, you'll hear people say, I don't believe climate change is real. I don't believe that we're causing climate change. Okay, that's an opinion. If you want to determine if climate change is real or if humans are playing a role, you need to look at evidence. Evidence is found in peer-reviewed scientific articles. Period. This isn't new, and this isn't rocket science, and it's not hard to figure out. Almost 14,000 of those articles from 1991 to 2012, of almost 14,000, 24 of them rejected human or anthropogenic warming, human-caused global warming. Now, by my math, that's greater than 99%. Jim Powell also, by the way, was appointed by President Reagan and George H.W. Bush. The hockey stick. We hear so much about the hockey stick. And you can't even see it, I'm sorry to say, over there in the far right side of your screen, but I'll tell you what happens. And along the bottom here, 600,000 years ago, 500,000 years ago, those are thousands of years ago. You see what the CO2 has done. We've learned this from chemical analysis of ice cores and fossil analysis and other means. You see what happened. We've been up and down, we've been up and down, we've been up and down. But if you go to the far right side, it shoots up at the very end of the scale. And what you're looking at are parts per million. The highest that you see up to 100,000 years ago in the atmosphere is 250 parts per million of CO2 concentration. If you could see the far right side of the scale, you would see it shoot up almost to the top of the chart, which happened this year. Several months this year, we measured 400 parts per million of CO2 in the atmosphere. So, yes, it does take the shape of the hockey stick. You may have heard recently, well, actually, the planet's been cooling since 1998. 1998 was a very warm year. We had the strongest El Niño on record in 1997, and as a result, that heat generated by the ocean transferred into the atmosphere, and up until some of the recent years, it was the hottest year on the planet. But, yeah, we saw some ups and downs. Sure, we saw some ups and downs in the air temperature over the last decade. But it's not all about the air temperature. The red line there indicates the long-term linear trend. You can't take a year, or you can't say, oh my gosh, it's so cold outside, it's been cold for a week. Where's that global warming? You know, it blows my mind, but I get tweets and I get emails like that. Where's that global warming, Jim? It's cold out there. You're talking about all the record lows. I just want to throw my hands up sometimes. You got to follow the trend. There's your linear trend in the red line, and there is no deviation from it in terms of what's going on. What people don't take into account is the ocean content. They're thinking air temperature. Air temperature. Well, we've seen the fluctuations. We're not seeing any fluctuation in the ocean content of the atmosphere. Those are the blue areas there. And it's the whole Earth system that you have to look at when you're talking about warming. Ocean, ice, land, air. And it's all trending up, with the ocean content really trending up, as are the global sea levels. Now, that looks pretty dramatic there, but that's in centimeters. Centimeters since 1995. So what does all this mean for Central Texas in terms of the climate change that's going on? And I'll be happy to talk with you or debate more about climate change. Again, I defer to the experts. I confer to the computers, because computers are not being paid or influenced by any lobby. They are crunching numbers. It is mathematics. And I believe in the math, and I believe in the science, and I believe in the experts. What does this mean for Central Texas? What are the local impacts of this climate change going to be? 3-degree average increase in temperature, 50% increase in the days over 100 degrees starting as early as April, 10% decrease in average precipitation, 15% decrease in the summer, and a 15% to 20% less surface water due to evaporation and precipitation. That is not good, as our population, of course, continues to grow. Those are the local impacts that we anticipate this century. If you'd like to read more about this, I recommend an excellent book from Michael Mann. You might hear him. He's kind of been a lightning rod for some skeptics, but that really does an excellent explanation of this book. Provides an excellent explanation of why the hockey stick became such a lightning rod. I was going to try to get everyone, any Cowboy fans, out of here a little early today to go get the game, but I was also told we are on television. We have a format. The format goes a certain length of time, and so we're going to continue to fill that length of time today. And so I would like to open the floor up to any questions you might have about anything. I've got lots of topics I'd love to talk to you about, including severe weather season coming up and changes in some severe weather safety rules that have taken place over the last couple of years. So no topic is off limits.
Okay. Jim Bryce, you have a question.
Thank you very much. Excellent presentation. Some of the projections went as high as approximately, I think it was 11.5 degrees Fahrenheit in the next century. I'm wondering if that is when sort of the worst case of things like the methane that's captured in crystalline structure is totally released in the atmosphere. Those kinds of tipping points, if you will, how those might work and how those statistics will come up in that context.
You know, I don't think they have a really good understanding yet with all of the impacts of an 11.5 degree warming over the next year, century. An 11.5 degree warming would have some impacts that probably we can't even wrap our mind around right now. When we have seen dramatic increases in the levels of greenhouse gases in the past, very bad things have happened, including ends of eras in our past millions of years ago, mass extinctions, really, really terrible things. And this is since the Industrial Revolution. This is the only time, looking back again at those ice core and chemical samples, that we can see such a dramatic increase over such a short period of time, other than in the past. Some skeptics will say climate's always changed. There have been times millions of years ago that there were a lot more greenhouse gases in the atmosphere than there are right now. That is absolutely true. That is absolutely true. But we also saw a mass extinction as soon as whatever caused that sudden increase. Plus, in a period in which there were greenhouse gases in the atmosphere for a long period of time, the Earth had millions of years to adapt to that change in the amount of CO2 in the atmosphere, and life grew to flourish over millions of years. But when we had this sudden spike in the gases in the atmosphere, thus the sudden spike in the global temperatures, or the sudden cooling, that's when we saw very dramatic and cataclysmic things happen. In terms of the increase, the hockey stick, we just haven't seen anything like that, other than cataclysmic events. I'm not sure I answered your question very well, but the increase in methane from the surface floor, yeah, those kind of things, who knows what could happen. And all of those are bad. All those are bad things. Nothing good is going to happen that I can think of from an 11.5 degree average temperature increase over the next century. I don't think we fully understand. Some scientists do. I don't.
Thank you very much, Jim. I wouldn't miss your program now.
Thank you so much.
How is the empirical data that you used for weather forecasting influenced by climate change?
Well, that's a very good question. As the new models, algorithms are created to improve our computer models, our forecasting, don't tell my boss this, but it's all done by computer. I have very little to do with it. No, we get computer model out. You hear us talk a lot about the computer models. Weather forecasting is done by computer models, plain and simple. Whether you like watching KXAN's weather or whether you like watching our competitors across the street at the other TV stations, we are all looking at mainly the same data. And they might have a computer model that I don't have access to. We happen to have a computer model that nobody else in town has access to. But that is all coming from the input. The initialization of those models is all coming from data that we all have access to. So we all look at the same thing. But the computer model sometimes will tell us different things. In fact, I could look at 5 computer models today if I went to work to do the weather tonight, and 5 of them are going to tell me 5 different high temperatures tomorrow. They're going to tell me 5 different probabilities of rain tomorrow. And so that's where the expertise of the local forecaster or meteorologists that have been in an area a long time that have learned to understand where these model biases are. Oh, I can forget this model because we're in this kind of situation, so I'm going to forecast it's going to be 30% chance of rain. I can throw out this model that's 70%. That just comes from experience. So that's why my forecast might be a little different than my competitor across town. And that's up for you to decide who does the better job of figuring out which is the most accurate model. But in answer to your question, as the scientists create the new models to predict the atmosphere, and models are simply computer programs that run, that analyze computer data, and it's just physics. What goes on out there is just physics. But we don't get to measure enough of the atmosphere to predict the weather perfectly yet. We may never be able to. But we're getting better and better at it, and supercomputers are getting faster and faster. Remind me to tell you about new supercomputers that are going online next year. But they take into account what we are observing now with the change in the atmosphere, with the change in the warming. And as they're developing the new models, they include that. Now, how much do they include projections in models that are going to analyze the weather now into the future? I'm not sure. I wouldn't think a lot because really you need to know. We're not sure exactly what's going to happen. We may have these fluctuations in the next few years. A volcano could erupt, and we might suddenly cool, like Pinatubo did. We might suddenly cool for a couple of years. So I think before they create a new model that's going to forecast the weather years down the road, they can't go too much on projections in the future. They kind of have to go based on what we understand is happening now. That's my opinion. There may be some influence.
Thank you for coming and talking to us. You've mentioned low temperatures and high temperatures in the future. What's the most probable increase in temperature range for the United States on the global warming issue? Very low and very high. What's most probable?
The most probable increase in temperature? Well, I think that's going to depend on where you are. For example, by global warming, we don't mean that everybody is going to warm. The impacts of global warming in some locations are going to mean a colder climate. In some locations, we're expecting to be drier here in Central Texas as a result and experience more droughts and more heat waves. There are other parts of the world that are expecting to be wetter and to experience more floods, and snowier and to experience more ice. So the nature of the heat transfer around the planet is going to change, and so that is not going to affect weather, which is different than climate. That is not going to affect weather the same everywhere. In terms of a number, I think it's going to depend. I've seen analysis for different locations, like the one I just showed you for Austin, Texas, or for Texas. That's how we're expected to be impacted. For other parts of the country, it's just going to depend. I think in terms of the southern plains, what I just showed you, because our weather patterns tend to be fairly similar, fairly uniform, I think what I showed you is probably about average. But I can't tell you right now in New England, for example, what the anticipated impact would be there. I would have to look that up.
Jim, thank you once again for being with us today and a terrific presentation to us. This is kind of a follow-up to what you just said previously, and that is with global warming. Has this made your job more difficult, and do you have greater or less confidence in your forecast because of that?
No, I would say we're not at the point yet that it's made my forecast more difficult or less accurate. I think it kind of goes back to your question. I think we are maybe taking into account now a little more as we make our forecast, skewing a little toward the hotter models, because the models are slower to react. We've got a model right now that was created back in the 1980s that we're still using today. It's been tweaked along the way, but we're still using it right now to forecast the weather. And I notice when that model is consistently telling me it's going to be cooler than it is. And so I will make that adjustment on the fly. The model says it's going to be 97 tomorrow. It's usually about 2 degrees too cold. It's going to be 99. But then again, that's being in an area, being somewhere and observing that mistake every day and making that mistake a few times. Once burnt. How's the saying go? Twice shy. Once bitten, twice shy. Yeah, exactly. So we learn from those mistakes, and I think that's what we will continue to do. So I don't think it's something that we consider every day. The new models that are coming out are really, really good. And I mentioned this a minute ago. It relates to computing power. We have supercomputers right now. And I hope you've noticed that our forecasts have gotten better. In the last a little over a decade, our fifth day in the 5-day forecast is as accurate. Now, this is closer to 20 years. Our fifth day in our 5-day forecast is as accurate now as our third day was, day 3, back 2 decades ago. And I'd like to take credit for that. Weathermen are getting so much better at forecasting the weather. Computing power. It is computing power and better modeling of the atmosphere. The computers analyze the atmosphere. They say, this is how it is now, This is what's going to happen tomorrow based on what's happened in the past. And we have supercomputers that we're using right now that perform 300 trillion calculations per second. In 2015, by the summer, we have new computers going online in Washington, D.C., at the National Centers for Environmental Prediction, National Weather Service, basically, that are going to calculate 3,000 trillion calculations per second, from 300 trillion to 3,000 trillion. So we're 10 times. That would be you computer experts out there. Teraflops. That would be how many? Is that 300? Is it 10 times? It's a lot. It is a lot. We're about to go 10 times the capability in terms of our computing power. So our forecasts are going to get better and better. You notice now when we're forecasting hurricanes, they put out that cone. That hurricane usually turns when it's supposed to. It usually stays in that cone, and the cones get a little smaller and smaller. We're getting really, really good at this. But sometimes we'll still miss tomorrow. So meteorology is not an exact science, and we appreciate your patience on those days that it's not.
Hi, I'm Elizabeth.
Hello, Elizabeth.
Thanks for being here today.
Thank you so much.
So it's great to hear about the weather, but also, I don't know if you have an opinion, or how does this affect, obviously, Austin, Texas's water supply?
Well, it's going to affect it in more and more ways. I mean, we're still in, I think, stage 2 drought restrictions right now. We've had normal rainfall, but we're still in drought restrictions right now because it's not the rainfall that's fallen in Austin, Texas. It's the rainfall that we're not getting back out in the hill country that has Lake Travis at a critically low level right now. And that is our drinking water. The Edwards Aquifer, despite our recent rains, is still below normal. Barton Springs flow is still averaging, it's right at average, maybe a little below normal. It's in an alarm drought stage, it's called. And with our population continuing to increase and our water demands increasing, if we don't get our lakes full or find more resources for water or find better ways to conserve, we've done great in conservation. There's no doubt about that. We still get to water, once a week. We still get to turn our sprinklers on once a week, right? So we're not in a dire situation yet, but I'm just hopeful that Dr. Gammon is wrong and that we are not in a cycle right now in which we are going to be mainly drought through 2030. That's not going to be good, and it could have some serious implications. We could go into situations in which, I'm not saying Austin, Texas, that we're going to run out of water, but there have been cities that have run out of water over the last 3 to 4 years, literally run out of water. Spicewood Beach up on Lake Travis, they've been trucking in water now for 2 years until recently they put a new pump in the water that went down lower into the lake. So that can happen. That can happen. And restrictions in the last couple of years in Round Rock, no car washing. Business owners that own car washes have had to close them at certain points. In San Marcos, you may not fill your swimming pool. That's happened recently. You may not wash your car, even hand wash on the driveway. We're not allowed to do those kind of things. There's a problem.
Thanks, Jim. My question is, if you could wave a magic wand and make some policy changes to help us avert the worst possible climate change predictions in the next 100 years or so, what type of policy changes would you wave that wand and create?
Thank you for that. That's a great question. And I knew with this group that I would have all excellent, fantastic questions, and you would put me to the test, and so far you've proven me right. If I could wave a magic wand, it would be to go back to the era in which partisanship was removed from decision-making at the political level. I remember giving addresses to Rotary clubs, etc., back in the early mid-1990s when we were already noticing the warming. And I would talk about global warming. And I wouldn't get any questions really much related about that. Certainly nothing. Nobody would ask me anything, would challenge me as to whether it was really. That never occurred to anybody to discount the science that we were seeing at that period. At some point over the last 1 to 2 decades, when it became an issue of right and left, it has become dangerous. They say politics is lethal, and it can be lethal. And when it results in decision making that does not take into account science that can have a direct impact on people's lives and health and safety, then that's a really, really bad state of affairs. And this is not a slam on Republicans or any particular political group, but the fact of the matter is this: 70% of the Republican membership right now in Congress have openly denied climate change. They have denied that humans. Some say deny the planet is warming at all. Some of that 70% group deny that the planet is warming at all. The flat earthers, I call them, because unless you don't believe in thermometers, then you cannot deny that the planet is warming. Okay, so some of them don't believe that the planet is warming at all. In fact, the chairman of the new Congress coming in, the chairman of the Environment Committee, which establishes EPA hearings and those kind of things, is the author of the book called, I believe, The Greatest Hoax, Global Warming and Climate Change, is the author of the book. Okay. And then recently a lot of them have been saying, well, I'm not a scientist. Exactly. Exactly. But that's not a way to get out of making decisions. You bring in scientists. You look at the facts. And so the fact of the matter is that we have decision makers right now that are responsible for making very critical decisions. And what magic one decision would I make? It would obviously, I think, have to do with reducing the amount of greenhouse gas that we are responsible for. I mean, that's a no-brainer. It's just a no-brainer. How can you say, we know, it's a fact, that when you put increased CO2 in the atmosphere, that it's going to trap heat. We can see that happening looking back before humans, populated our continent. That when natural occurrences happen in the atmosphere that increase suddenly CO2 and gases, suddenly we trapped heat. We know that happens. So therefore, does it not make sense that if we're putting this into the atmosphere out of power plants or wherever the CO2 emissions are coming from, that we're trapping heat? It's just so logical. And with the implications that the scientists say are down the road for us because of what we're doing. So what if we're wrong? If tweaking these things and decreasing the amount of CO2 we're putting in the atmosphere really doesn't help, well, at least we gave it a shot. But when the odds are, and 97% of the science agrees, that it will help, do you not try? Based on the serious ramifications of not doing something, it is just such a no-brainer. So, wow, I got long-winded on that answer. My question was, this isn't, again, independent, Democrat, Republican, I don't care who you are. My question, my answer is, and my magic one would be, please, can we magically remove our prejudices based on our ideology in politics and focus on science and the scientific method and evidence, black and white. There can still be disagreements. I've got a couple more minutes.
Maybe you've already answered this, but as a weatherman, you're able to predict a hurricane or a tornado. But the question is, can a tornado or a hurricane be caused? Is there any way to affect the weather rather than just predict the weather?
Weather modification, that's a good question. Cloud seeding works. There are cloud seeding experiments or cloud seeding projects that are going on right now across the state of Texas. We have George Bomar, who wrote the book Texas Weather, great book, by the way, who is in charge of licensing of those cloud seeding projects here in Texas. We know that it works. The problem is you've got to have the right kind of clouds to seed before you will enhance the amount of precipitation that they will produce. And when you don't have enough moisture in the atmosphere, you're not going to get the right kind of clouds. are we able to modify the clouds enough that they're making a significant difference? I think that the jury is still out on that. So we do some modification, and mainly in the form of cloud seeding. In terms of modification of hurricanes, tornadoes, there is nothing that I have ever heard or read of that has been proposed that might alter, that development. Someone has, suggested in the past, why couldn't you, detonate a nuclear bomb in the hurricane, in the vicinity of the hurricane? Well, because you're detonating a nuclear bomb. But even that, those things are so massive and involve so much energy that there's little I think we can do. People are wondering if wind farms off coasts won't disrupt weather patterns. Again, in the overall scheme of things, in a planet, ocean, atmosphere system, that has very little impact. So nothing yet. Once we figure something out, it's going to be great, though, that we can stop a tornado. Our best hope is that we are able to predict tornadoes farther in advance. We have gone from a negative 2-minute lead warning back in the early 1990s. In other words, we could tell you about a tornado 2 minutes after it was there. Our lead time in our tornado warnings was literally negative 2 minutes. Okay, this is late 80s. And now our lead time on tornadoes is over 12 minutes. Sometimes it's 20, 30 minutes because of the improvements that we've made in Doppler radar, allowing us to look at the wind in the tornado, and scientists and researchers better able to understand what we're seeing when we look at that and give people warning, especially in big tornadoes. We rarely miss big tornadoes, which are the most deadly anymore. So we're getting better and better. Tornado fatalities are coming down as a result. But then you'll have a horrible, horrible event like Moore, Oklahoma, or like Joplin, Missouri, which have all happened within the last 4 years. And you'll realize that we have a long way to go. We've got to not only warn people, we've got to make sure they get the warning, and that they do the right thing once they have the warning.
We want to thank you for making a mysterious subject much clearer and more accessible to all of us. And thank you for your wonderful work and for being willing to present to us today.
Thank you all very much.
Today.
Thank you
Let's
for having me.
Let's give him a big hand.